floor plan. And then beneath that, it has some assumptions that I've made. So it talks a little bit about VoIP phones, talks a little bit about coverage, and also the client throughput. It explains the building type options that I could have entered, and it talks about, the fact that buildings and what their coverage looks like. So it's really kind of explaining the background as to what a predictive model is. And it's very useful to give this to the customer. I've got a series of assumptions there, and there you can see some guidelines here on the gain of the antenna, the client transmission power if you're doing data, receiver sensitivity, etc. So it's giving the client again some valuable information that you can sit down and explain that to the client as to how this tool works and how you came up with this prediction. So it explains a little bit about how the site survey uses intelligent algorithms. And then here, as you come down, it talks about the criteria of how it placed those access points. And then what I really like is it provides this map that shows where it's suggesting that it puts the access point. And again, there's nothing to stop you moving these access points. So if you say, hey, I've been out there and I've done some measurements and I'm going to move these access points in these locations and regenerate the heat map, you can still use this tool to generate this nice survey result, giving you those placements. So if you come down a little bit more, it talks here about the access points that we actually chose in this model. And again, we chose the 3500i with the internal antennas. Now, if I'd use an access point with external antennas, it would also describe those external antennas, talk about whether they were directive or omnidirectional, etc. And it also gives some information about the maximum transmit power of the access point. And then what's really attractive is it now gives me the heat maps. And so this first one here is for the 5 gigahertz band. And above it you can see what those RSSI measurements actually are. So you can talk about the minimum measurement that's required for voice, and in fact we've put it there as minus 67 dBm. We come down a bit, you can then see the coverage map for the 2.4 gigahertz band. As we talked about before, no surprises, that is a better coverage because the signal doesn't attenuate as much in the 2.4 as it does the 5 gigahertz band. Then, in addition to the heat maps, it's now going to give you the data rate heat maps. And so this one now is showing the data rates that you can expect to be able to achieve across the deployment site. And so this is looking pretty good that most people will be able to get up and have fairly high data rates. That's in the 5 gigahertz band and also again in the 2.4 gigahertz band. And lastly, it just talks about the coverage analysis. And what's really nice here is it's talked about the received signal strength, and it's given you some indication, hey, there may be some areas that maybe the coverage isn't good enough. And this is really important because, I can move those access points to tweak them slightly to improve that. Maybe move to an external antenna to focus more energy in one direction to recover that area. So there's several options that I can look at, and this tool is kind of pointing me in the direction to say, hey, here's the area that might be problematic. That's probably an area I want to go and make a few extra measurements and work out, especially if I think there's going to be any interference sources there. If I've got a weak signal plus interference, I'm going to have some major problems. So this really kind of points me in the direction where I might spend a little bit more time on my site survey. So what you're seeing here is that the Cisco wireless control system is capable of generating some really nice reports that I can create from my site survey and give to my customer. They look very professional and they really illustrate a lot of the things that I want to be discussing with my customer around their wireless LAN deployment. Now, this tool creates it. There's a lot of tools out in the market, including the Air Magnet Survey Pro that creates these reports. My main recommendation here is that you should choose a tool that not only gives you good, accurate prediction, but is able to create these reports, because it will save you a lot of time and effort as you're trying to pull all that information together in order to hand it over to your customer. Now, this tool, potentially, you could actually generate it and actually leave it on the day that you actually do your survey right there on the customer site, which would be pretty impressive. So deploying your wireless LAN is more than just determining how many access points you need. You also have to consider the total installation requirements. So how does it integrate and interwork with the existing wired network? And that's what we're going to take a look at in the next part of this lesson. So one of the first things you want to think about is the environment that the access point is operating in, and whether you need to house that access point in an enclosure. Now, the table below gives a sample of some of the enclosure types that are defined by the National Electrical Manufacturers Association. And I've also shown here that the Cisco 1550 series outdoor mesh access points actually conforms with the enclosure type 4. You can see that an enclosure type 4 is protected against the ingress of water caused by rain and snow and sleet that can occur outside, as well as the occasional hosing down. It is also protected against dust and other fiber that might be in the air. However, you'll notice that this is not protected if this access point was actually submersed in water. And if you wanted that kind of feature, or you wanted protection against corrosive agents, then you'd need to go up to a higher number in terms of your enclosure type. I've also mentioned here that the Cisco 1550 outdoor mesh complies with the IP67 requirements as well. Now, the IP ratings are very similar to what you see being produced by the National Electrical Manufacturing Association, except these are published by the International Electrotechnical Commission, the IEC. So they're basically two different rating systems by two different organizations. So now you've decided on what type of enclosure you want for your access point. The next thing you need to think about is, how are you going to mount the access point? Now, the options for mounting your access point vary depending on whether you want to do it indoors or outdoors. In an indoor location, you might want to put it on the ceiling or the wall. In the outdoor environment, you might need to put it on a pole or an external wall. Now, a couple of considerations: if you're deploying it indoors and they're looking for you to deploy it above the ceiling, so you always want to deploy it below the ceiling if you can, but if they say no, you have to deploy above the ceiling, maybe that's for aesthetic reasons, then you might need to hang the access point from a ceiling rail. And again, there are different types of brackets and connectors that will facilitate those different types of deployment options. Now, if you're deploying the Cisco 1520 802.11n series outdoor access point, this has 3 different configuration options, and you need to think about that prior to the deployment and make sure you're specifying it correctly, and it may change your mounting options. The cable option has 3 antenna connections on the top, and it can be powered with PoE, so power over Ethernet. The pole option is shown in this diagram here, and it has 2 antennas on the top and 2 antennas on the bottom, and it supports a fiber connection as well as several other different power options, which include powering it from the streetlight. The mesh configuration option also has 2 antennas on the top and 2 antennas on the bottom, and it can support a connection to the wired network. but it doesn't support any wired connections to cable or fiber optic. And deployments of access points outside need to be installed by an installation specialist that understands how to correctly ground equipment and meeting the local regulatory building and electrical codes. So we've talked about the access point housing, now the mounting. Now we need to talk about the antennas. And so if you're using an access point and you've decided to use external antennas rather than internal antennas, you need to think about where those antennas are going to be relative to the access point. So when it comes to the Cisco antennas, with the exception of the standard dipoles, which just connect directly to the access point, the antennas will come with a cable. And Cisco actually offer two different types of cables. There is the low loss and then the ultra low loss cable. The typical length of all the cables is 36 inches, but you should check that when ordering your antenna to make sure you know the length of the cable. Now you want to place your access point and your antenna as close as possible together to minimize the loss on the cable, but there are some times when you have to place your antenna and your cable further apart, in which case you may have to order some additional cable. Now the cable can come in various lengths, and so you want to be able to estimate how long the cable needs to be and make sure you're adding that to the order list. And of course, if you're ordering antennas and cables, do not forget the connections. So most antenna cables will come with an RP-TNC plug on one end and an RP-TNC jack on the other end. But you should always order some spare connectors just in case. Now, if you have a deployment that's outside, you need to protect your antenna from possible lightning strikes. And so for outside deployments, you would actually install lightning arresters to prevent any energy surges reaching the RF electrical equipment itself. So next on the list is to think about how are you going to power the access points. Now an access point can be no further than 100 meters away from where your PoE switch is, and 100 meters is 328 feet. So if the Ethernet cable that's going to be powering your access points is over 100 meters long, you need to start thinking about power injectors. And power injectors, as the name suggests, inject power into the Ethernet cable. But power injectors need to be powered as well. So you need to look at where your power source is and where can you insert a power injector to make sure that your access points have sufficient power. So two things you need to check. You need to check the power requirements of your access point, and when you do that, you also need to take into account the losses that you might incur when you're dealing with a very, very long cable. Now, if the access point does not receive enough power, what you're going to find is that some of the antennas may be disabled. So if you're trying to do a 3x3 or a 4x4 MIMO deployment, you may find some of those antennas are disabled and you're only able to get perhaps a 2x2 MIMO. The other thing can happen is that the radios can turn off, or it may keep rebooting itself. So it's really